Anyone who can solve this problem is definitely a little academic star. Let's read the question together. Look, it asks you to find the result of 7/12 minus 9/20 plus 11/30. Many students, when they see these three fractions, immediately try to find a common denominator to solve it. It's slow and easy to make mistakes. So, is there a better way than just finding a common denominator? Today, let's follow Teacher Dong and discover a pattern together. Actually, these three fractions are a bit special. Can you see what's special about them? If you slightly change the numerators and denominators, what form do they take? Let's write it out. Look at the denominator 12. If I break it down, what is it as a product? Isn't it 3 times 4, right? 3 times 4 equals 12. Now look at the numerator. It's 7, which happens to be the sum of 3 and 4, right? See, this kind of form is quite special. What do we call this? This is called... We've talked about this key concept before. Both Mujizi and Teacher Dong have explained it. What does it mean? I'll explain it to you in detail in a moment. Let's finish writing it out first. Now, look, how can we transform this next fraction? Can 20 be written as 4 times 5? And 9/5, isn't that just the sum of 4 and 5? Right? Let's write it as 4 plus 5. What about the last fraction? 30 can be broken down into 5 times 6, and the numerator is 11. See, isn't that 5 plus 6, which equals 11? All right, let's write them out again as these three fractions. So what does Mujizian mean? Let me give you an example and you'll immediately spot the pattern. For instance, we all know how much 1/2 plus 1/3 is, right? You find a common denominator, don't you? What do you get? 2 times 3 is 6, so it's 2/6 plus 3. Isn't that right? So how did you get the denominators and numerators here? For the denominator, you get the denominator by multiplying 2 by 3 and the numerator by adding 2 and 3, right? That's forward thinking, but you also need to be able to reverse it and work backwards. So look, 2 times 2/3 plus 3 can be written as what? It's just 1/2 plus 1/3, right? Similarly, once you've mastered this pattern for these fractions above, tell me, they must all come from adding 2 unit fractions together. Look, here it's 2 times 3, and here it's 3 times 4. So thinking in reverse, 3 times 3/4 plus 4 can be written as what? Isn't it 1/3 plus 1/4, right? And this one, 1/4 plus 1/5, but there's a minus sign in front, so you need to use parentheses. And when you remove the parentheses with a minus sign, what do you have to do? Change the signs, right? So just change it directly and it becomes minus 1/4 minus 1/5. No problem, right? This all has to be correct. Don't make mistakes. When you remove the parentheses and change the signs, what about the next part? 5 times 5/6 plus 6, what does that become? Isn't it 1/5 plus 1/6? Let's write a bit more. Add 1/6. Now, looking at this, do you think we still need to use a diagram for this problem? There's absolutely no need anymore, right? Is there a shortcut method? This 1/4 minus 1/4 cancels out, and minus 1/5 plus 1/5 also cancels out. You're just left with 1/3 plus 1/6. When you find a common denominator, what do you get? Over 6. 2 plus 1 is 3/6, and if you simplify one more step, that's 1/2. Easy to solve. Did you get it?